Okay, let's get started. Okay, so again, this is our last lecture on program flow. So this is after this lecture, if you want to see if we're looking at our progress, we've basically gone through introduction, the tools, problem definition, developing UMLs, functions, variables, pointers, and we'll continue finished flow. So after this, we have basically finished the basics of a programming language. So with what we learn up to the end of today's class, we can basically do anything. After this, we are now starting how can we make things more efficient or better for the user. So that's what we'll be moving on next after this. Okay, so that's where we are right now, and we'll do, after that, the last parts will be arrays and probably a little bit of records. Okay? So that's basically where we are right now. So today's class, last week we looked at conditions. Today we looked at loops. Today we'll first of all take up the homework, repetition and gravity, file input. That's gravity section 5, loop, page 32, your homework for today. Then Rahim will be giving a few quick lectures. And then we'll have a break. Then we'll work through the decision and repetition to root, so that's application. We'll have probably about an hour to do that. We'll then take it up together, and then we'll have a chance to retry milestone 2, 3, 4, or milestone 5, try 1. For homework, there will be 2 homework readings, reading about flow in the book. That's general section 4 flow, page 14, and also pre-reading about arrays in SDBA section 2.1 and section 2.2. That's the textbook that's in the library. Okay, so we're starting to move into data structures. Okay, that's why that will be working with that. So let's start with moving on to the homework. First of all, taking up the homework on gravity. Okay, so I will stop this guy and move to our gravity, which is, if we're looking here, we were looking at converting this. This was our pointer code that we're going to convert to add this. And this is, when we're doing this, we want to use this sort of file, so we're reading in from it. So I'm going to save link as. Let's save this right down into our SDBA folder. Okay, and so if you want to look at this file, we can quickly open it, and we can use Excel if you want, or Calc to open it up, or Notepad. Anything can open it up. Let's look if we open it with Excel. Just once. Okay. So this is what the file looks like in Excel. It's basically the data file of the following object, right? The height and the time. Height, time, height, time, height, time, height, time, height, time. Although I think I got something backwards here. Whoops. This is not the way that these guys are mixed up. These guys sorted backwards. Sorry about that. Data. Okay, I'll have to fix that. But these guys should be opposite way. Sorry about that. That's good. It will also give you, so that would be this guy and our pointer code that is running. We already have that pointer code. You saw here it's running nicely. It had the 3 functions, one to get y and t, one to calculate the derivative, one to calculate the mean. And then we just had the main little section of the program right here. So our task now is to move, your homework was moving from that into, so right down here we're looking at gloop. I will download it and then we'll open. Okay, and then show. Okay. All right. So following objects. We've been working from the problem definition. We've dropped the thing from the building and it's dropping, and we're now going to implement repetition. So this is our existing code, which I was just showing you. You can see how we have 3 functions, the function prototypes, the main function, the function definitions, and it's running okay. But this code has some problems. each time we do the calculation, we must restart the program, right? So it doesn't make sense. Secondly, we need to enter the same numbers twice, right? For each data point in your book, I didn't enter the numbers twice. And this can't read data from a file easily. So our solution is to do it in repetition. We want to do all calculations with a program restart. Then we'll not have to re-enter numbers, and we can read data from a file. Okay, so this is what we're going to try to work on. We worked on for homework. So this was our initial UML. Read H1T1, read H2T2, right? You then calculated the average time and the velocity at that time, and then we saved V and T average. So our new version, we're going to want to add repetition. In other words, we're going to want to loop. So where are we going to want to loop? So if we're adding repetition, we must also have a stop condition, right? We have to know when to stop reading the file, reading the data, or it'll just run forever and ever and ever. So we can use an input that will never occur. So in this case, negative time will never occur. So we'll just input a negative time, and that will allow us to have a stop condition. With our stop condition, we can then then we can move the UML in here. Okay, so basically, this is the part that we're going to want to repeat. So we can basically run this in through here. We save VT. The next time we run it, the previous H2, what's in H2, we'll put into H1. The previous time, we'll put into time 1. We'll read the next time from the file. And when we read that next time, we'll then check. If T2 is greater than or equal to 0, we need to keep going. If it's not, then we'll end. And we'll then save the velocity and the time, read the next line. Read the next height. Store the previous height in H1, read the next height, come back in to our loop. So with our repetition, we now have repetition. So what type of loop do we want to use? Okay? When we implement this guy. So we'll now move to implementation. First of all, you can see we've got all these things have already been written. Okay, this part has already been written. So and I'm not going to modify this function. I'm not going to modify this function. I'm not going to modify these functions. So I've got my reading is being done by a function txt. I don't want to modify it. I don't want to modify this function. I don't want to modify this function. I don't want to modify this. So none of these things I'm going to modify. I just have to add a few things to the function main. This one, which puts H2 into H1, T2 into T1, and I've got to add a loop structure. Okay, so I'm not modifying any function other than function main. Okay, so now I have three choices of what loop structure to enter. Right? We have three ways of doing loops. For, in which we initialize, we have a condition, then increment, then statement to execute. We have while loops, and we have do while loops. Okay? Let's looking at our code here. First of all, this is not going to be useful because we don't know when to stop. Before we get the data, we don't know when to stop. We need the data. It's based on the data we decide to stop, right? When someone enters T2 less than 0, then we want to stop. So this one we can't use. This one, the testing is after you do the loop. In our example, the test is before the loop. Okay, so I got my test block before the loop, right? At the beginning of the loop, not the end of the loop. Therefore, I'm only left with a while condition. So I would then start to code the while condition. Okay, so basically this is what I've got. I'm going to start with this main function. I just said we're not going to change any of the subroutines. So all I have to worry about is my function, our main function here. Okay, and now let's move to Notepad and do our modification. Okay. Okay, no I don't, okay. All right, so I'm trying to modify this. So file open. I just want to look at, okay, I should have downloaded this, I think. I should have downloaded it. This downloads. No, I didn't download the C. Okay, I'll have to download that then. Come here, downloads, get my pointer guy, copy. Move back to Notepad. Here we are. Okay, no, that's not Notepad, not put on that side. Notepad, cancel, Notepad. Paste, file, save as. Go back to my directory, C, SDBA, change my file name, let's call it, this is going to be loop.c. Okay, let's make him big. Okay, no, I don't need this anymore. I'll close this guy, I'll move this guy back, move this window out of the way. Okay, so there's my main thing. Here's my UML I'm going to be working from. This part I don't care about. I'm not going to change anything down here, so I might as well kick them out of the way so I don't have to think about them. This is the area I'm interested in. Okay, what have I got here? Read H1. Okay, there. Okay, there's the reading. Okay, this is where my loop is going to start. So I'm going to, my loop, I'd say I got read 1, read 2, loop. Okay, while comes in here. What's my condition? T2 greater than or equal to 0. Okay, there's my condition. Okay, these guys are now inside a loop, so I'm going to indent them. Okay, these guys all in the loop. Next statement here is H1 equals H2. Okay, in my case it's Y1 equals Y2 and T1 equals T2. Okay, that statement's there. My next line says I should read H2 and T2. Okay, I've already got one here, so I'll just copy this. Okay, so now I'm reading. Okay, and I return control. There's nothing else to do. The control goes back to here, so finished. Okay, the coding is finished now. We have now done the short modification. Let's now make sure we can run it. And I haven't made any errors in terms of my syntax errors, which I seem to like to do. So where are we? Okay, so you're coming over here now. Okay, great. Okay, so directory, what have I got here? Okay, I have my loop.c and mgdt.c, good. Okay, gcc minus c minus wall loop.c. Okay, no errors, good. gcc minus c minus, okay, gcc minus o loop.exe loop.o should be okay. I'm not calling. I don't have any John input library here, so I don't need to worry. I don't have to have any other files. There's no other files I need anything for. So standard. So it's just loop. Okay. Now I can do loop OOP, and let's start to see what happens. Okay. Loop. Okay. It started to run. I just have get X and T. I'm not doing any prompts, so I'm going to have to just remember what I'm supposed to do. H and T, so let's say 42.5, comma 0, 39.3, comma 1. Okay, input next X and T. Okay, that would be 36.2, comma 1.5. Okay, it gives me the next value. Input the next one. -1, comma -1. Let's stop. Okay. Now we have the other file type. Okay, the CSV file directory. directory, okay, directory, okay, loop, let's input mgdt.csv. So this is what it's telling me. This is a command into Windows, okay? It says replace standard input by this file, okay? So I'm no longer getting data from standard. Standard input is now mgdt, okay? It's not the keyboard anymore. This is a Windows command that says, okay, standard input will no longer be the keyboard. It's going to be this file. Okay? And I run it. And you can see it provides all this stuff. Okay? Now, since I'm reading from a file, I'm going to want it, and I'm doing so much data, I'm going to probably change my file a little bit to make it more nicer, to make my output look nicer. So I'll probably change this command, and I'll put a /n here. And since I'm reading from the file, I don't need fprintf. So I'll get rid of that too. Okay? I don't want that anymore. I don't want a prompt because I'm reading from a file. So I'm going to get rid of the prompt. And instead, I'm just going to have it output. Okay? So I'll save this. I'll compile again. Oops. I hit the wrong button. Okay, hit the wrong screen. Okay. GCC minus C, GCC minus O, loop, mgdt.csv. Standard input is now coming from the file. And whoa, it just went through the whole file, did the calculation, and then output. Okay, so it read the whole file and gave all the velocities and the basic time. Okay, now I can change this again. mgdt.csv. Now this Windows command says don't change the output, standard output. Standard output is now being changed. Standard output will now be my new file. New. I'm going to call it velocity.csv. Okay? I can give it whatever name I want. I'm going to give it the name velocity.vle.csv because that's what's in the file, right? So now it's going to get the info from mgdt. It's going to put it into a file velocity.csv and I run. Okay? You don't see anything going to the screen, so I can now use a command. I can just say vel.csv and Microsoft Excel will happily open and I'll be able to see in Microsoft Excel the results of my calculations. Okay? Now, let's close this again. So now that I have velocity time, I could then say, okay, let's put velocity as my input, and I'll make a new file, acceleration.csv, to calculate my acceleration. Okay? And click. Okay, act.csv. And Microsoft Excel will be very happy to open it, and there's a problem. And we immediately see what the problem, let's look at the problem. I'm going to use, let's open the file. File open. I like, okay, velocity.csv, can you see a problem? What's the problem? Okay, look at my loop condition. T2 greater than 0 it loops, right? And when T2 is, how does it exit? Right, it has no -1. So I'm going to have to add a line -1 to tell it, hey, stop. Okay? I'll just put that -1 there, and we'll try to run it again. This should be Yes, please, 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 run, 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 run. I think it should work okay. Or did I forget my carriage return? 2. Try again. Control C. Okay, I'm not sure why it's not being uncooperative. Unless, do I have something open in leave some other files? Okay. Okay, I'm not sure why he's not being suitable. Do I open acceleration in something else? Let's see what I've got open in. Okay, not sure why he's not why he's.
Because there is an extra comma at the end in the.
Oh, do I got an extra? Oh, okay. All right. Thank you very much. There's another problem. Okay, open. Very good. Thank you very much for. Okay, you can see in my thing scanf said don't look for a comma at the end, right? I didn't put a comma there in my scanf. Here I've got an extra comma, so I got to get rid of the comma. Good, thank you very much. It's got to look identically the way I've got it in my reading command. Okay, let's try again. This time, oh, great. Thank you very much. And we can open again with Excel. Hopefully this time it looks, yeah, okay. So it looks okay. And there's the acceleration due to gravity. For this one, 9.47, 10.67, 7.63, 12.2, 9.93, 10.03, 9.45. Let's just, I'll use Excel now to do an average. The average acceleration, and the average is 9.9. Okay, so my experiment on average is pretty okay, right? What is acceleration to the gravity is what? 9.8? Okay, well, not bad. Okay, close enough. All right, experiments are never exact, so as long as it gets sort of close. Okay, so from this, I hope so that would be our gravity guide, and let's move on to here. Now there's our code here. All right, we ran the code. Okay, there's our code, we've run it. Now let's walk through the code and analyze how it's working. Okay, there's loop.c. Okay, first line has declares all our variables in main. Next line, we get y1 and t1. Okay, we read those two numbers in, 42.5 and 0.00 times e to the minus 9. We get the next one, 395 and 0.78, e to the 0, right? Okay. And we check. T2 is approximately 0.78. Okay, it's greater than 0. We enter the loop. dy dt calculates dy dt, and we get a negative number. Okay, for the velocity. Okay, we then call c mean. It gets us the mean value of t, and we print out the value. The next line sets t1 equal t2 and y1 equal y2. Okay, so basically this number is copied into here, this number is copied into here. We get y of t, good. And t2 we check. T2 is actually greater than 0, so we enter the loop. Okay, calculation dy dt, calculation of t, the mean. All right, and then we print. Okay, the printing is coming out to the screen. And, t1 is now equal to t2 So t1 equal t2, y2 equal y1 is y2 is put in, and then we read this. And this time I'm reading -1, -1. I come to the while loop. T2 is now -1, which is less than 0. This condition is no longer true. Condition is false or 0. When on a false condition, it means it's going to jump out of the loop and go straight to the end of the program, which it jumps down to here and returns. And that brings us to the end of that code. All right. Now we're going to move to our next part for today's lecture. We're going to have, where's our main thing saying our next step is, according to this, it should be flowing with Raheem, and then some insights with Raheem on why we're using coordinates. Okay, so these will take a short break and some time for Raheem to give this.
So we have a lot of different kind of operators. Okay. Good. Smart. Okay. So for relational operators, we have a back thing. You must have seen these: equal to sign, greater than, less than, exclamation mark, equal to, greater than, equal to, less than, equal to. For logical operators, we have this ampersand, ampersand, two rods, I don't know what they are called, and an exclamation mark. And for arithmetic operations, we have plus, minus, multiplication, divide, and this is called a modulus operator. Okay, so when we are doing conditionals or loops, what we are trying to see is, do we want to do this or do we not want to do this? So for that, what we need is, we need a condition. A condition tells us whether it is true or it is false. Okay, and true usually means 1 if we are talking about binary, and false would mean 0. But when we are coding, anything that is not 0 is also then considered to be true, and false therefore stays as 0. Okay, so what are we trying to do? A condition that gives us whether something is true or false. So conditions can simply be, let's say we have a variable called x of long type, and we say, is the variable and x equal to 5, and we say x is greater than 5, greater than 6. So is x greater than 6? No. Right? So that means it's false. Right? So let's have an example now that you know about the condition. Before that, we have this relational operator called equal to. So there's equal to simply, and there is equal to. What this means is, whatever container you have over here, any variable, let's say x, will have the value of whatever you write over here, right? So in this case, if we write 5, then x will have the value 5. Okay, but equal to means that the value over here should be equal to the value over here. If it is true, if it is the same, that means it's true. If it is not, otherwise it's false. So this way we are giving a condition. I have a question now. Let's say we have a few variables called long, x equal to 77, y equal to 66, and z equal to 606. Okay, any random number. Okay, so x equal to y equal to z. Can anyone anyone tell me what the value of x is? Say it louder. The value of x.
66.
No.
0.
No.
77.
No.
No.
No. 1. Okay, so what we are doing, whenever we are calculating, we calculate first thing what is in the bracket, right? And whatever this value will be goes into the container, right? So what was this? This means this thing has to be equal to this thing. This is 66, this is 66. It is
Yes, sir.
equal. That means true. True means
1.
so x will be 1. Okay. Similarly, you have a variable, again, x. Give me a number. Look at it.
30.
Okay. If I had to print this, so much writing, print s, SED out, percentage LD, and we're printing x. If we do this, the output will be 3. If I had to print this, what would be the output? Oh, by the way, the logical operators. Do you, you're EE, right? EE or ECE? Which department? Huh? So you must be knowing logical operators, right? What is this? You know, like and or not. You will add in like circuits. You know that, right? So circuits are also about true, false, and everything. So whenever we learn to make a truth table, right? So we say, okay, what we're trying to do is we're trying to learn about the AND operator, right? So if we have a true and we have a true, what happens? It's true. If we have a true, we have a false, false, and false true, false, false. Okay, simple. You know the logic. How about true or false? True. But what about not of true? What is it? False, right? So how would you say that? You would just simply say, okay, this is just a representation, okay? This would mean false, right? So if printing x was 3, what would be if you print not of x? 0. Good. Awesome, Luca.
Yes.
0, right? And okay, what if x was 1? Then yeah, still 0. Come on, is it easy question? Yes. So basically, what I'm trying to say is, you will get to know that. What if x was 0? Yes, it will be 1. So again, through this we understand that any value other than 0 is a true value, okay? And 0 is basically false. So we're trying to put up a condition. Any condition is a greater than that. Is it equal to, are both the sides equal or not? If it is not equal to, this is the opposite of this, right? If it is greater than equal to. So we're trying to have a condition. And if we want to have two conditions, we can have some logical operators, right? And then we can do some arithmetic operations to do some calculations. So whenever we're doing loops or conditionals, what we need is a condition. Going to the next thing. Now, this is something that I like a lot, but we don't really use that. We don't use it so much. But just to get a logic. Again, what I'm trying to teach is what you would say logic, okay? Or I would say playing with programming. So you don't really need to be like, I don't know, I haven't passed milestone 3, I don't know coding. This is just understanding. You can still understand. Okay, so let's say we have a variable called x, and we don't know the value of it right now, and we have a variable called y, and the value is 2. Okay, so if we had to calculate x modulus y, by the way, modulus means remainder. Remainder. What is the remainder? What is the remainder of this? Good. What is the remainder of this? What is the remainder of my hand is so black? 2. Good. Okay. So you're getting the remainder. But what is this if we are doing long calculation in long? 2. If we were doing calculation in double, then what do you mean 2 point something? We are Asians, we're smart in math, come on. Good, 2.5, not 2 point something. Okay, so we do some calculation. Okay, so x is any number. Give me a number this side. Number 5. 5. Good. Okay, so 5 modulus 2 will give you 1. Okay. What if I increase the value of x? Okay. Let's say we did x plus plus. Okay. So 6 modulus 2. 0. Okay. So if I am increasing x, the possible values are 0 or 1. Right. So let's say now our the value of y is 3. Okay. Now x modulus y. Give me a value of x.
0, 1, 2. Oh. 3 billion.
Write it down.
I think.
How many zeros in a billion?
No.
Think before you speak. Okay, give me a number. Good. Okay. So 4 modulus 3 is
1.
1. Good.
Easy.
Let's say we increase the number. 5 modulus 3 is
2.
okay. Let's say we increase the number
0.
0. So what are the possible values? Okay. So from this, what we understand in a like logic wise is that any number modulus y, the value would range between 0 and y minus 1. Okay, so this way you can just have numbers between a certain number. And right now you don't know where you can apply this, but I will tell you where you can apply this. So next thing, now that we have understood what a condition is, we can now start learning about using if. Give me a number. Peter.
2.
You're slow. Okay. Long, equal to 2. Okay. So now I want to see. Really? Okay. So is this true or false? True. Simply. How about this? How about yes? And if I am making a condition like this, what am I checking? Let's say it's any number. With this condition, what can I check? What can we check? What can it? Stanley, what can we check?
Tell me the answer first. I think it's wrong. So.
If we are getting a remainder with 2, we can check if the number is even or odd. If this is true, this means it's even. If it is false, that means it's odd. Okay, so for checking if any number is odd, for checking if any number is even, condition. Okay, next one. Is this condition true? Yes.
Yes. Yes.
What about this condition? False.
False.
Yes. Good. Alright. So now you understand what conditions look like. So we can go to something more beautiful that I like, and that is loops. Okay. So why do we use loops? So that we are lazy and we want to do things again and again, and we don't want to type. Right? Just like gravity, we have a file, we put the file, it does the work for us. We don't have to type it one by one. Okay, what is H1, what is T1? Okay, so we do loops. So I'll write two simple loops so that you can understand. I'm going to talk about two loops, for and while only right now. Okay, so for, I'm not writing the whole code, I'm just writing the part that is important. Kimmy, how about you come here? Come here. I mean, you can come over here so that you can see clearly. It's hard to see over here, I think, this part. Okay, long I equal to 1, I is less than equal to 5, I plus plus. So does anyone know what we are doing with this?
What will be for five?
Good. What about now?
What will be for?
Good. Okay, so you understand the difference. If it is this, we're doing 1, 2, 3, 4, 5. But if it is this, till 4. Okay? Now, how does this go? It initializes a value. Okay, I'll tell that later. And now I'm going to write a while loop. So we use while when we don't have any initialization, when we just want to check the condition, right? But if you want to look at for and while side by side, they're similar. You can use whatever you want. And we can look at the syntax for this. So for loop, what we're trying to see is we're trying to initialize a variable. We need to put a condition to check when to stop, and then we have a certain increment. Okay, and we do something over here. For while, what we're doing is, if we were to change this code into while, what we would do is we would do the initialization first. Then we would put the condition in the while. And inside the loop, we would do something, and then we would do the increment. Okay, so it's similar. Now, how does this go? It's like, how do we calculate? So I is equal to 1. Then we check the condition. Is 1 less than equal to 5? Yes. Do this. Now, when we go back, we increase I. Now the value becomes 2. Is 2 less than equal to 5? Yes. Do the work. Again, increase. Now 3. Okay. Is it? Yes. Do the work. Again. Now it becomes 4. Is it less than equal to 5? Yes. Do the work. Go back again. 5 is yes. 5 is less than equal to yes. Do it. Now when it becomes 6,
No.
the condition is,
Papa.
so we stop. Okay. Now this is where the fun begins. I like it. So now that you understand 4, we can play with 4. Okay, so I is 1. What are the numbers?
1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Good. What are we printing?
1, 3, 5, 7, 9.
Good. What are we printing?
2, 4, 6, 8, 10.
Good. What are we printing?
1, 4, 7, 8.
So we can do different things, okay? Just to play around to understand how loops are happening. So this way we can say we are printing the first 5 even numbers, right? This way we can say we're printing the first 5 odd numbers, right? Let's say we want to say we want the sum of first 5 numbers. Okay? 1 plus 2 plus 3 plus 4 plus 5. Okay, so we have a simple loop. I'm not gonna print anymore. And this is right, okay. And we have a variable sum initialized to 0. Okay, and then we say sum equal to sum plus I. Okay, so what happens is sum, okay, remember anything before the equal to is a container. It has no identity, it has no value right now. Whatever the value that it will have is whatever we calculate on this side. Okay, so sum at this moment is 0. 0 plus 1? 1. Okay, so in the first loop, 1. Then next loop, the value of sum is
1,
1. Okay, 1 plus
2,
2. That is
3,
I has become 2 now. Okay, so 1 plus 2, 3. Next loop, the value of sum is 3. I has become
3, 6,
okay. Next,
6, 4, 10, 5, 15, 15, 6, 21.
no,
Oh,
it stops. Okay.
yeah.
So what is the sum? Now calculate 1 plus 2 plus 3 plus 4 plus 5. What is it? What is it? I don't know. Time. 15? Yeah, it's 15.
Yeah.
You sure? Sure. Now let's say this was a variable called noun. Okay. Simply, we're just calling it. We're just changing it. Okay. What if instead of plus I was doing this, multiply? What would happen? What is the answer?
0.
You sure?
Yes.
Why?
Because number is 0. 0 plus every number is always 0.
It's gonna be 0.
Yeah.
So, like, what would you do? What would you change now?
1.
This will be
1.
good. Now we can multiply each number. Okay. Okay, so another thing that we can do is that we have, so instead of going like increasing 1, 2, 3, 4, we can also go back, right? So let's say I is 10. Okay, we're not using long anymore. We're just playing with this right now. We're saying, forget this. You guys tell me. I equal to how much? What is the condition? And what is the increment or decrement? I want to print 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. How would I do that? I equal to 10. Okay, good.
Bigger and big or equal to 1.
So I should be greater than equal to
1.
1.
good. And
Minus.
I minus. Good. What should I change?
Bigger and greater and equal to 0.
Good. Okay. Now, if I was to say that, what if I make this? Now what am I getting?
8, 6, 4, 2, 0, 0.
Yes. now one interesting thing that we can use remainder for. Give me a big number.
1 trillion.
How many zeros in a trillion? How many in a billion?
是吗？是吗？是几个？啊？
Okay, Bill. Give me a number. Yeah, sorry, Bill. Bill, Hank. Paul. Paul? Okay. Bill, give me a number. Change. No back up. Kevin, give me a number. Give me a bigger number. Okay. Okay, let's make it 51. Okay. So what would happen if we were to divide 51 by 10?
1 or 5?
Huh?
5.
No, the number is long.
5.
5. No, if it was double, you would get 5.1. But this is long, so 5. Round down. Okay. And what would happen if it was this?
1.
1. Right? So let's say I give you a number 1, 2, 3, 4, and I say print each of these numbers. How would you do that? If you had a number 1, 2, 3, 4 and you divide it by 10, what do you get?
1.
But if you had to do this, what do you get? So if you did this, you got the last number, then you did this, you would get now 123, and you did this 3. So you're getting another number. Now, what do you get?
12.
12. Okay, again 12.
2.
So you understand? Now you can get each number. What if I tell you, I give you a number and you have to add each of these? But right now I'm doing it manually. You can do this enough? Okay, so this is somewhere you can make it with the remainder. Okay, just for fun. And of course, divide. And that is the end of it. Thanks.
So you can also, so right now we're on this section here, repetition to roots. So we're going to be using in your book, root section 5, flow, page 52 in your book. So page 52 is where we're going to be working through. Page 52 in your book. Okay, page 52. All right. Okay, so if we find page 52 and okay, so, all right, assume we find page 52. Okay, this comes to here. All right, so first thing you're going to want to go is to our webpage and download r6pointer.c. Okay, under flow, r6pointer.c. We're going to be modifying this program. So please download r6pointer.c. Okay, from iJu SDBA, okay, so r6pointer.c is what you want to download. Down to flow, here, this guy right here. r6pointer.c, please download. And once you download, save it with Notepad. Okay, Notepad++, you want to copy it into.
Alex.
Okay, so okay, so root finding pointer we should have, so save it into here and just save it into your whatever. Okay, so you should be getting it from here. on our main page. Okay. So our 6-pointer. And I'll close this guy, and we can. Okay, as you download that. Okay, we've downloaded them, we'll start to continue on. Okay, so we're going to be we're looking now at the square root problem again. We want to look at using repetition and condition, and we're going to basically create a function to calculate the square root. Okay, basically our own function square root. Okay, this program we have right now only does the square root of 2, right? We're manually entering xs, xb each time. This is quite stupid and very boring. The computer should decide the next x to try, and so we need to automate with repetition. So you can see right now, what we've done right now, we input xs, input xb, we find the mean, we run the equation, we hardcore the 2 because we want the square root, and basically there's our x squared. Down here, it's going to do that, update it, and we have to keep going each time, right? You repeated it again. So we should automate this. So in order to do that, we first want to change our UML. Okay, let's look at our current UML. Okay, there's the UML we're working for our code that we have right now, right? Our program starts, we fix P. Right, we have the fixed P right there. You can see, if I look here, you can see as our program starts, we fix P. For example, here I fix P equals 3 right here when I called the equation. I inputted XS and XB. Oops, my mistake. XB, XS and XB I input, and then I calculate the middle. I called equation for y equals x squared minus p, then I output x and y, and then I did the job of trying to figure out what my next x would be. We want to modify this UML. So we're going to want to put a loop in here. When we're thinking about looping, we're going to want for our program, all we want to do is to have to input p and then get the output square root. That's what we want. We'd like a black box. We input P, we get the output X. That's what we want. Okay, so let's start to build it. We already have CMean to do this calculation. That's a function. We also have a function equation doing this this. So here's our change. We input P, but we let the program we're going to let our subroutine start with xs equals 1 and xb equals p, because we know the square root is going to be between 1 and p. We'll bring this in. If p minus 1 is greater than epsilon, we'll enter our loop. Epsilon is how accurate we need the answer, because we always have to tell how accurate do we need it. Do we want 10 decimal places? Do we want 20 decimal places? Do we want 2 decimal places? Okay, we then take the mean, we take the root, then goes the decision. Remember how we decided if y is less than 0, that means that xs can be increased. If y is greater than 0, that means that xb can be decreased. So in other words, if when we use this x, we find that y, let's say I'm looking for the square root of 2 squared. So if I try 2 first, 2 squared is going to be a positive number 2. I know 2 is too big, so that I can reduce xb by a half. Okay, so 1.5, we try again, and we keep rotating around and around until we are less than epsilon. Then we output our x. So let's go back. Sorry, I'm going to go back. So this was our Okay, sorry. So this was our original one that we've been, our program right now. This is our new UML. We've added a loop and a condition. Okay, because we have to decide whether we want to go smaller or bigger, right? Our next step is to decide the functions to use, our pseudocode. What functions are we going to modify? Which ones are we going to use? But I'm going to do it on this diagram rather than writing the code myself. Because this is a short function, I don't have to write the pseudocode. Okay, so let's look at how we go to pseudocode. First of all, I already have cmean. I'm not going to do anything here, I don't want to touch that function. I have equation. I don't want to touch that function either. I'm going to need to make a new function croot. It's going to need two things. What I want to take the root of and e, and it's going to include all this is what I'm going to include in my function croot. And that means the stuff at the top is going to be my main function. So my main function is just this stuff at the top. And now you can see it's basically a black box. When I call my main function, the user just inputs the number, they get the square root out. So everything in the middle is going to be a function, just a croot call, which is like going to be a black box to the main function. Okay, main function will call croot with the number it wants p to be, and it will then give me the output. The next step is going to be to move to C code. And note, now I only need to input one input. I'm going to use get float prompt. Just input what you want the square root of. I want the root of, and then the number you want the square root of. We'll just put till the input only p, and we have epsilon. So our next step is to modify the code. So you're going to download our var and start to modify the code so root is found when the user enters a number. So we download this code, look at our UML diagram, which is this guy, right? This is what's going to be your guide. You're then going to create a subroutine croot, and in that subroutine you're going to use repetition and decision. That subroutine is going to call cmean and equation. Do not change cmean or equation. Don't change these two functions. These functions should not be changed. Okay? But we're going to put just a simple function call in here and replace. So main is just going to be integer main, and then it's going to call croot, then it's going to print the example, and croot is going to have all this stuff inside it. Okay? So you can look back to our UML, and that's basically the task that we'll be doing now for the next, say, 30 minutes, I guess. At least 30 minutes we'll work on this. Okay, so I hope you can start to work on that. I'll leave the UML on the screen for you, and this is the task that you're trying to do. Creating the subroutine croot, basically this subroutine in here, and the main. So each function, you have an outline of what it should look like. Okay, so let's let you get started on that now. On the modifying of this C code. The C code R pointer is the one you're modifying, is this C code right here that we just downloaded. In other words, we're not going to touch this function. We're not going to touch, so these functions down here, nothing down here gets touched. Basically, you're going to be creating a new function, right? Your croot, you're going to have a function prototype, proto croot, croot. You're going to have a definition of croot, and basically you're going to have a call for croot somewhere in here. Like it's just going to be, you're just going to have a call for croot, like y equals croot of whatever the person wants the croot of after the get float prompt, right? You're going to have the call up in here. You're going to have a call in here. And basically, this is no longer going to be here. This is going to be moved to croot. This is going to be moved to croot. Okay? This is going to be basically no more. We just want to replace with what we want the root of. Number 2, find root. And, oh sorry, the call is going to have to come in here, right? Sorry, not there, okay? So that gives you a quick idea in terms of putting into pseudocode what we want to do, looking at our UML diagram. Okay, so I will be quiet now, and the TAs will be walking around. If you have any questions, we'll try to help you with that. Okay. Okay, we're going to show a little bit of the answer, but we're not going to finish the answer, but I'm going to try to give you some guidance on this. That's maybe the thing I would like to do now, try to understand this. Okay. This is basically our program right now. What you're trying to do is to model this guy, right? So that here we've got 4 functions, equation, mean, and root. Equation and C-mean aren't being changed. C-root is. So the main equation is just going to be very simple. I have a P and an X variable in my main program. So I just have double X, comma, P. I want to get flow prompt. What do I want the number of? I want the get flow prompt. I want the square root required, for example. I want to give a prompt. So I'm getting the number in other words, so I could just put double P equals the square root of prompt. Okay, so that's the number I want the square root of. I then need to call my function. X, it's going to return, it's going to calculate the root of P, and then I'm going to print it. Print F, standard out, first ampersand LF, P, and return 0. So that should basically be my main program. So all this other stuff, this stuff here, X equation of P, this stuff is all going into C root. So this was Control Z, oh sorry. These guys are going to go into C root, which I'm going to define down here. And the main, I'll get main down there, okay? So my main program is actually going to be very short. All it is going to do is calculate the square root. And if you want to look at a similar program using the library function, Java has actually coded one to try to demonstrate how to use it using library function. This time we're writing our own function to do it. That's the only difference. Okay, and then here's where you've got you'll need your prototype. For example, double, it's going to return a double. It's going to C root and double what I want my square root of. And maybe I want to put double precision. How accurate do I want my number to be? Okay, I could do that as my statement there. And then I need to then write my function. Okay, all right, and then in here I have to write my C root function. It's going to contain this function and other stuff in here, the while loops and everything. It's all going to be in here. So all my work has to be done in this Control Z, sorry. Control Z, what are these guys? Control X, Control V, and everything else is going to be in here. Control X, a bunch of stuff in here. 有在这里应该很多东西要写，全部的东西是写在这里里面。But these two functions are going to be here. So you can see basically how main is operating. It's just calling get flow prompt, and then calculating C root. If I wanted to make this even shorter, if I would like, okay, pardon? Oh, group meeting is, okay, so you can see our main program can be very, very short here. If we wanted to, we could actually put my double here as well, initialize and declare and initialize all in one line. So that would be the main program. It's only 3 lines. I think that's roughly equivalent to what, okay. So and you have your second one, and then what you want to call C root, and maybe I'm having a precision, so maybe 0.001 is my precision I want it to be at. Okay, so my epsilon. Okay. All right, so you can continue. So that gives you some idea in terms of writing the main function. So now we have to do the looping and stuff. Just have to write this C root function. Okay, which includes these 2 declarations. Initializations, and then into the loop. Okay, guys. So when your program is finished, you'll get stamped, and after you have the thing working, you can go home. Okay. So that will be the end of the class after we get this finished. Okay, and your program is running.